Okay, so if you look at these ones are all on their side, so that means they involve, if you notice that when you see this has eyes in it. So it's arg z plus 2I on z minus 2I equals 3 pi on 4. Now something about the y one, when you've got z minus z1 on z minus z2 equals positive theta, then arg of z minus z1 minus arg of z minus z2 equals theta. That actually, like if this is z1 and this is z2, that actually represents the arc on this side. So for y, it's kind of back to front. Now, if you want me to show you why, I could. This is steps a little bit out the side of the syllabus, but I still think it's good to see. There are some of these in Fitzpatrick as well. Now, the other thing about this one, though, can you see that it's got the z plus 2i? So it's the argument of z plus 2i minus the argument of z minus 2i equals 3 pi on 4. So it's kind of back to front. So that means if you multiply by minus 1, then you get it the right way round. It equals minus 3 pi on 4. So when you make it a negative angle, you just flip it over to the other side. So the normal y1 is actually back to front, so it's on this side. It is an obtuse angle, so that means it's going to be between D and B. But because it is back to front and it's a minus 3 pi on 4, that means it's going to be D. So just making that really clear. So just make it really clear. When the theta there is obtuse, that means it's a smaller arc. Okay, so it's just the top of that. But when the theta is acute, then it's a major arc, like this, on the two circles. Okay, with this one here, the centre is there, and with this one here, the centre is there. And whatever your angle is, like that's the centre, if this is 2 pi on 3, that actually ends up to be 2 pi on 3 as well. Because that there is double it, which is 4 pi on 3, and they have to add up to 6 pi on 3. And with this one here, if we drew the angle at there, like if that was pi on 3, then the angle in here is 2 pi on 3, and the centre is inside there. So if you just draw a quick picture of these, basically this one here, like if you've got minus 2i and 2i, and it's an obtuse angle, it's going to look like that. That means your centre is somewhere down here. That's your centre. And the angle here is 120, so that would be 240. That is 120, so that's 60. So you can actually get... Oh, sorry. I put eyes on those. So as soon as I put eyes on those, they are the y ones. Sorry, take that back. So as soon as I put y's on them, that's 2, that's minus 2. The normal y1, and this is an obtuse one, will go there. So that means that this here is 120, and that will go there, and that would be the centre of the circle. This will be 120 because that's 240. And from there, we can actually get what that point is there, because we have a right angle triangle. That's 60, and that's 2. So if we drew that up, that's 60, 2, and that's x. So you go tan 60 equals 2 on x. X equals 2 on tan 60. So it's 2 on root 3. So the centre is 2 on root 3, 0. And then to get the radius, that's that there, so we'll call that y. So you go sine 60 equals 2 on y, y equals 2 on sine 60. Sine 60 is root 3 on 2, so it ends up being 4 on root 3. When you're doing this one here, that's going to be the same thing. It's going to be on this side, but it's going to be a bigger major segment. And if that's 60, the centre is somewhere in there at 120. So if that's you can get the right angle triangle. If that's 120, that's 60, etc. I'll let you figure that out. And the one that's, if you've got arg, and say you've just got 2 on z plus 2, and say that equals pi on 6, then that just means that you go here and here, minus 2 and 2, pi on 6, so it's a big obtuse angle. This is probably more normal. That's 30, and the angle at the centre is 60. So from there, you know that that is 2, that's 30, so you can get y, and you can get the radius r just using trig. So if you made that like this way round, then that just flips the angle to a negative, because it's the same as having arg z plus 2 minus arg z minus 2, which is pi on 6. So if you multiply by minus 1, it's arg z minus 2 minus arg z plus 2, and it equals minus pi on 6. And like that just flips it to the other side like that. And that's minus 2 and 2. The only other thing to remember here is if the angle theta, if theta equals 0, and like you've got these 2 points, if theta equals 0, it's on the outside, and the theta equals pi, then it will be inside, because it looks like a line, and that's outside.